Okay, we are attempting to make our first video lesson. We will be learning about plate boundaries today. There are three major types of plate boundaries, depending on the motion of the plates relative to each other. Number one, we have divergent boundaries. Notice the arrows moving apart. This is where we have plates separating from each other. Number two, we have convergent boundaries. Notice the arrows moving towards each other. These, of course, will be where plates are converging. And number three, we have transform boundaries, which we will see are plate boundaries where the plates are going to slide past each other. So notice we have the arrows here sliding past each other, going in opposite directions to represent our transform boundaries. Okay, so three major types of plate boundaries: divergent, convergent, transform. This is the best I could do with the lighting in this classroom. All right, so we will begin with number one, divergent boundaries. Again, notice the arrows moving apart. In this case, we of course have plates that are separating from each other. We're going to have two different settings for that. The first is called a mid-ocean ridge, MOR for short. That's in an oceanic setting. We can also call that a spreading center. A good example of a divergent boundary in an oceanic setting is the mid-Atlantic ridge. Okay, our second type of divergent boundary, part B, number 1B, is called a rift zone. And a rift zone is in a continental setting. We can also refer to this as a continental rift zone. And our best example, really our only example of an actual rift zone on planet Earth right now, is the East African Rift. So let's move over here and take a look at some of our, trying to get the, there we go, maybe that's a little bit better. Let's take a look at some of our hazards that we're going to find, geologic features or hazards. All right, so at the mid-ocean ridge, we will have volcanism. It is basaltic, and of course we know that new basalt oceanic crust is being formed at our mid-ocean ridges. We tend to have shallow earthquakes here. We tend to not have tsunamis. For the most part, a mid-ocean ridge does not have to hurt anybody. Now, moving on to the rift zone, the continental rift zone, like the East African Rift. What are we going to have? We are going to have crustal stretching. We're going to have shallow earthquakes. It can be a decent size, believe it or not. And we will eventually get volcanism if the rift does not fail. So you may remember from your class notes that the area of New Madrid, Missouri is a failed rift, as in the North American continent attempted to split apart many millions of years ago, and that rift failed. So we do not have a small linear ocean basin in Missouri, but we do have large earthquakes from time to time. Hi, I'm filming. Okay, we're going to pardon that interruption. There are people using rooms all over this building. We are now going to move, oh, you know what? Back to the notion of a rift zone. We might say that Pangaea splitting apart and forming the Atlantic Ocean, that's an example of a continental rift that did not fail. Moving now over to convergent boundaries. So this is number two on our three major types of convergent boundaries. And we have three types of convergent boundaries, A, B, and C. So we'll do A first, which is ocean to continental subduction zone. We can call it OC for short. All right, I'm going to pan back as much as I can. I'll try to let you see the drawing. What we have here is we have an oceanic plate that is sinking beneath the continental plate. I have left the MOHO out of these drawings. The MOHO is, of course, the crust lithospheric mantle boundary, but I've left it out to make it simple. So notice that the continental plate is thicker, and the continental plate is also going to be less dense than the oceanic plate. Remember that the dominant rock type for a continental plate is granite, and the dominant rock type for an oceanic plate is basalt, and the basalt is more dense. So we'll zoom in a little bit to talk about the hazards or geologic features. What happens here? Well, the oceanic plate sinks as it is more dense than the continental plate. We will have a chain of active volcanoes on the overriding plate. We call that a continental volcanic arc. A good example of a continental volcanic arc would be the Cascades in the Pacific Northwest. Why do we have volcanism? So there's three things here that look like little teardrops. Those are representing melt drops. So we basically have dewatering of the downgoing oceanic slab, and that is going to cause partial melt of the upper mantle above it, and that is going to fuel our magma chamber here and our active volcano. All right, zooming back again to finish talking about the hazards. So we will have active volcanoes to deal with in this kind of plate boundary. We will have strong earthquakes of various depths, and yes, tsunamis can form here. I think it is true to say that subduction zones, be them ocean to continent or ocean to ocean, are the most dangerous plate boundaries on the planet. Now we're going to zoom over here and take a look at a good example. Hopefully that light reflecting isn't too bad. The Cascadia subduction zone in the Pacific Northwest. This comprises Northern California, Oregon, and Washington. And the Cascades, you see that there in quotes, the Cascades is the mountain range we find there. It is our continental volcanic arc. Let's now move over to convergent boundary number 2. And I'll have to play around with where I'm going to stand with the camera. We'll try it back here. No, that's not great. Move a desk out of the way. Pardon the interruption. Okay, maybe that'll do. Okay, so this is convergent boundary. Convergent boundary is our second type of plate boundary. This is our second type of convergent boundary, so we're calling it 2B, ocean to ocean subduction zone. Notice we have O to O, ocean to ocean subduction zone. Here is a drawing. Notice that the thickness of these plates is relatively the same. Notice where the water line is. These are both oceanic plates. So what's going to happen here? Let's zoom in a little bit. All right, so what's going to happen is that the older and more dense of the two oceanic plates will sink. We are going to have a chain of active volcanoes on the overriding plate because we have dewatering of that slab, and we call this a volcanic island arc. What else will we find here? Well, unfortunately, we can have really strong earthquakes of all kinds of depths. We can have tsunamis. Our best examples, my favorite examples, are the Mariana Islands and Mariana Trench in the Pacific. Very famous location. Remember that the Mariana Trench is the deepest part of any ocean basin in on this planet. And of course the Aleutian Islands, which are up there kind of south of Alaska. If you ever watch Deadliest Catch, that's where they are fishing. So the Mariana Islands and Trench and the Aleutian Islands are really good examples of this. Let's just pan up a little bit and look at this drawing again. So notice that our active volcano here is not really part of a landmass. It is an island. It has formed an island because it's a volcanic island arc. All right, moving on to our third type of convergent boundary called continent-to-continent collision. We could just call that CC. I'm not going to make a drawing of this because I don't do a good drawing of this, but you guys do have drawings in your PowerPoints. We're going to move around relative to the light glare. Okay, so what do we have here? Two continents, both thick and low density, both made of granite. So we don't have a subduction zone. We don't have any subducting slab. Therefore, we have no partial melt. Therefore, we have no volcanism. What will we have? Extreme crustal thickening, mountain building, regional metamorphism, strong earthquakes, landslides and avalanches. We will not have tsunamis here. We will not have any active volcanoes here. Our best example, of course, is the Himalayas, where you have India crashing into Eurasia. And do they have earthquakes in the Himalayas from time to time? The answer is yes. We've seen that a couple of times in recent years, and there's been tragedy every time it happens. All right, moving on now to our third and last type of plate boundary, the transform boundary. The transform boundary, what happens here is you have two plates that are going to slide past each other in what we refer to as a lateral motion, which just means side to side, just as those arrows are drawn. So what do we find here? Large strike-slip faults. The most famous large strike-slip fault that is a transform boundary is, of course, the San Andreas Fault in California. So what are we going to have in a place like this? We are going to have strong, shallow earthquakes, for sure. We hear about earthquakes in California a lot. Not all of them are due to the San Andreas Fault plate boundary, but plenty of them are. We will have no volcanism. There's no partial melt being produced. We will have no tsunamis here. And it's fair to say that as exciting as our land-based transform boundaries are, like the San Andreas Fault in California or the North Anatolian Fault in Turkey, that most strike slip faults on this planet are actually those fracture zones which are on the mid-ocean ridges. Okay, hopefully this worked out well, and we'll try this again, perhaps on Monday, with volcanoes.